Hello guys, this is your Dr. Piri again taking you in physiology. This is human physiology. So we've started looking at circulatory system. So far we've covered about two lectures. Today we'll be looking at lecture 3. In this lecture 3, we'll be just looking at the electrocardiogram recording and also some cardiac arrhythmias. So this is lecture 3. Circulatory system lecture 3. So in this lecture, what we're going to look at, we'll look at ECG recording, then we'll look at heart blocks and cardiac arrhythmias. So because there's a bit of information here, I'm going to split this class or this lecture in two parts. We'll have the part A where we're just going to discuss ECG recording, and then the part B where we're going to discuss heart blocks and cardiac arrhythmias. But you need to remember that in the previous lecture, we looked at the normal ECG and how those waves and also segments come about. So I hope you remember the basics of the ECG, or the basis or the principles of the ECG. So under normal circumstances, we're supposed to do the ECG recording in the lab, in the physiology laboratory. But because of COVID-19, we're unable to do that. So I've just added information for you to appreciate how you can do an ECG recording. And also when we open the university, you'll be able to do a lab. Then by then you already have the information about the ECG recording. So it will be very easy for you to relate. So let's start by looking at the ECG recording. So you remember we said that there are electrical activities of the heart that will bring about the myocardium to contract. So the SA node is firing an action potential that will be propagated via the conductive system of the heart to stimulate the atria and later on the ventricles that are going to contract. So as you are having these electrical activities of the heart, we say that these action potentials, the electrical activities can spread to the surrounding tissues of the heart. In these surrounding tissues, this electrical activity can also spread into the body fluids, because we said the body fluids are good conductors of electricity. So they will be able to conduct these electrical activities of the heart to the body surfaces. So if you put electrodes on the body surfaces on the skin, you'll be able to pick up the electrical activities of the heart. Why? It's because you have this good conductor of electricity, which is body fluids, and then they can conduct that electricity to the body surfaces. So under normal circumstances, we have what we call the 12 lead ECG machine. 12 leads ECG machine. So there are electrodes that you connect the body surfaces. For you to appreciate any electrical activity, at least you need to have 2 electrodes that you connect to the body surface. Then you'll be able to pick up the potential difference and to give you information about how the heart is performing. So there are 10 electrodes that you connect to the body surface, but these 10 electrodes will give you about 10 information concerning the heart. So that's why it's called a 12 lead machine. It will give you 12 leads about the heart, the electrical activities of the heart. So you're looking at the heart from different angles or different aspects. So there are leads that are looking into the heart from different angles. Remember, the heart is a 3-dimensional structure. So for you to appreciate what is happening around the heart, you need these 12 leads that are looking at the heart from different aspects or from different angles that I'll be explaining to you. So because it's a 12 lead machine, these 12 lead machine, there are 2 different types of leads. So there is what we call the unipolar leads and the bipolar leads. The unipolar leads, from the word itself, unipolar, it means you have one major electrode that you're using as a reference to look at the heart. The bipolar leads, you have 2 electrodes that you're using as a reference for you to look at the heart. So you have unipolar and bipolar. So this is the information that I want to share with you guys. Let's start. So there are 2 types of ECG recording electrodes or leads. So you have the unipolar and bipolar leads. The bipolar leads, there are 3. So you have lead 1, lead 2, lead 3. These are called bipolar leads because we have 2 electrodes. So where are you going to connect those electrodes? For lead 1 here, you're going to connect a negative electrode on the right arm, then the positive electrode to the left arm. Then for lead 2, the negative electrode on the right arm, the positive electrode on the left leg. Then you have lead 3, the negative electrode on the left arm, then the positive electrode to the left leg. So these are called bipolar leads. That's why you are connecting those 2 electrodes at 2 different parts of the body. So left, right, left arm, right arm, left arm, and also right arm. That is for lead 1. Then the right arm to the left leg, lead 2. Then left arm and left leg, that's lead 3. And then you also connect an extra lead on the right leg. That is called the ground lead or the earthing. Then you have the unipolar leads, and these unipolar leads, they are 9. So there are 3 unipolar leads which are called augmented voltage leads. So the augmented voltage leads, you have 3. You have AVR, AVL, AVF. So AVR, they are called unipolar. So you're only having 1 electrode that you're connecting to the body surface. So the AVR, you have 1 electrode that you are connecting to the right arm. So this is called AVR. Then you also have another electrode that you're connecting to the left arm, which is called AVL. Then the other one to the left leg, which is called AVF, F for foot. Then on top of that, you also have 6 unipolar leads. These are called chest leads or precordial leads. They are the ones that you connect on the chest in the 4th intercostal space and 5th intercostal spaces. So these are V1, V2, V3, V4, V5, and V6. Other textbooks, they'll give you C1, C2, C3, C4, C5, and C6. These are called chest leads. So they are also unipolar. So you have 1 reference point, then the machine will create an imaginary lead, then that lead will be used as a negative lead, and then you'll be able to appreciate the electrical activities of the heart. So these are the 12 leads. So another extra information on how you place the electrodes. So here you have the name of the lead and also the placement of the electrodes. So it's basically the same information. So you have the bipolar leads 1, 2, 3. I've already explained how you're going to connect them. Then you have also the unipolar leads. I've also explained how you're supposed to connect them. So you have the AVR on the right arm, the AVL on the left arm, then the AVF on the left leg. Then you have the chest leads starting from V1 to V6. So V1, you're going to put your electrode on the 4th intercostal space to the right of the sternum. So how are you going to locate the 4th intercostal space? So you need to feel for the sternal notch. So you have this sternal notch, then you palpate downwards until you feel the sternal angle. Once you find the sternal angle, then when you move to your right side, you're going to feel the 1st intercostal space. Then like that, you go down to the 2nd intercostal space, 3rd intercostal space, until you reach the 4th intercostal space. So just adjacent to the sternum, you put your V1. Then you do the same to the left side. Now within the same 4th intercostal space, adjacent to the sternum, but to the left of the sternum, then you put your V2. Then your V3, you put it in the 5th intercostal space to the left of the sternum. So 5th intercostal space. So from the 4th, it will be very easy for you to locate the 5th intercostal space, but to the left of the sternum, this is where you put your V3. Then your V5, you put in the fifth intercostal space in the line with the middle of the clavicle. So you have your clavicular bone here, or the collarbone. Midway, you go all the way down until you are in the fifth intercostal space on the left side of the heart, on the left side of the body. This is where you put your V4. Then your V5 is still in the fifth intercostal space, but to the left of V4. So where you put V4, just to the left of V4, in the fifth intercostal space, you put your V5. Then your V6 will be in the fifth intercostal space in the line with the middle of the axilla. So you have the axilla here, or under the armpits here. So just the midline of the axilla, this is where you put your V6. So you can see that the chest leads, you are putting them on a horizontal line. So from the fourth intercostal space, then you jump to the fifth intercostal space, all the way going towards your lateral side of the body. So these are the chest leads. So they're looking at the heart in a horizontal plane. The other limb leads, they're looking at the heart in a vertical plane, or a coronal section. So they're looking at the heart in the vertical plane. Then the chest leads, they're looking at the heart in a horizontal plane. That's why they're located on the chest here. So they'll look at the arterial aspect of the heart, then also the lateral aspect of the heart, especially the left side of the heart, because this is where you have major ventricular contraction. So you are able to pick up strong signals of the electrical activities on the left side and not the right side of the heart. Okay, so this is called the Einthoven's triangle. So they are the same leads. So here you can appreciate the bipolar leads. So the bipolar leads, you have lead 1, 2, and 3. So if you put an electrode on the right arm and left arm, so your right arm to be negative and your left arm to be positive, this is called lead 1. So there is an imaginary line here that is connecting the right arm to the left arm. But remember, these electrodes are connected to the machine, the ECG machine. So this is just an imaginary line that will exist. It's called the axis for lead 1. So this axis for lead 1, you can see it's looking at the heart from this point of view, coming downwards here. So this is lead 1. Then if you connect negative electrode on right arm and the positive electrode on the left leg, this will be your lead 2 here. Then if you connect your negative electrode on the left arm and your positive electrode on the left leg, this will be your lead 3. So you are forming this isosceles triangle. At the center, you have the heart. So the easier way to remember where you're supposed to put your negative lead or electrode and the positive electrode is by looking at this. So this is left arm with one L. So where you have L, you have your positive. Where you have L, you have your positive. So left arm, you only have one L here, so you have one positive for lead 1. Then on the left leg, you have two L's here, left leg. So you're going to have two positives. So you have one positive for lead 2. So since your positive is here, your negative will be that side. And then you have another positive for lead 3. So if your positive is here, the negative will be the other side. So you know to say that the right arm, there is no L, so there is no positive. So it's all negative. So it's negative, negative. So this is called the Einthoven's triangle. Then down here, you can see the placement of the chest leads. So you have the V1. I told you to say you need to feel for the sternal notch. Then you palpate downwards until you find the sternal angle. Then the sternal angle, when you go to the right side, you'll be in the first intercostal space. Then you feel for the second, third, and fourth intercostal space, just adjacent to the sternum. This is where you put your V1. Then you do the same, you feel for the sternal angle, you palpate for the, you feel for the sternal notch, then you palpate for the sternal angle. When you go to the left side, you'll be in the first intercostal space, then you feel for the second, third, and fourth intercostal space. On the left side of the sternum, this is where you put your V2. Then you go into the fourth intercostal space, but on the left side of the sternum, this is where you put your V3. Then again, within the fourth intercostal space, but midway, mid-clavicular line here. So you have the clavicular bone or the collarbone here. So midway of it, but within the fifth intercostal space, this is where you put your V4. Then you put your your V5 just adjacent to the V4. Then you go the midline of the armpit here. So you can see under the arm, you have the axilla or mid axilla. This is where you put your V6. So you can see that V3, 4, 5, and 6, they are within the fifth intercostal space. Then V1 and 2, fourth intercostal space. So these are looking at the heart in a horizontal plane. So you can see here mainly that V1 and V2, they are basically looking at the anterior aspect of the heart and bit of the septum. Then these other ones, they're looking at the lateral aspect of the heart. So we'll discuss that as well. So we proceed. So this is the cardiac axis. So you need to know where the limb leads are found within the cardiac axis. So I want you to understand this circle here with these angles. So we said lead one is straight here. So you can see from the right arm to the left arm, this is where you have lead one. So your positive is here. So this is a straight line. So when you draw this circle, it means when you put a straight line at the center of the circle, the straight horizontal line here, this will be the axis for lead one. So lead one is at 0 degrees. On the other side, it will be 180 degrees. This is your lead one. So as you go upwards this side, you are approaching negative values. As you go downwards here, you're approaching positive values. Remember, this is more like the mirror image. So it's opposite. Upwards, it's negative. Downwards, it's positive here. So we said that this horizontal line, which is straight here, it's lead one. So now, when you come down here, you have those augmented leads. The augmented leads, you just put them on the extremities. So they're also called limb leads. So you have the left foot here. So this left foot, if you put an electrode here, looking at the heart this way. So this augmented voltage foot. So it's called augmented voltage foot because it will be looking at the heart from the left foot just down here. So it's looking under the heart here, the ventral aspect of the heart. So you can see it's a straight line here, which is vertical. So at 90 degrees, this is where you find your AVF, augmented voltage foot. Why? It's because it's located here. So the ECG machine will take the average of the right arm and left arm electrodes. Then you to put an imaginary negative electrode at the center here. Then it will draw a straight line to the left foot. And this axis is called AVF. So the AVF is at 90 degrees. Then the other augmented voltage left and right arm, So for the right arm, so you have AVR, the augmented voltage right arm. It's looking at the heart from the right shoulder downwards here, diagonal here. So from this angle, you have isosceles triangle. So let's say this is 60 degrees, this is another 60 degrees, and this is also 60 degrees. So if the AVR is cutting this angle in two, looking at the heart from the shoulder here, but the imaginary line is drawn from here all the way this side. So the machine will take the average of the left arm and left leg, then it will draw an imaginary negative electrode here, then to connect a line to the right arm. Then you have your AVR. So your AVR is splitting this 60 degrees into two. So you have 30 degrees. So if your lead one is straight here, giving you this 180 degrees, then it means your AVR is 180 minus 30. It will give you 130. So when you go 30 degrees upwards here, you have 150 degrees, which is negative because it's the other side. So AVF is at 150 degrees, looking at the heart from this angle. Then the other augmented voltage left arm is this one here now. So this is where you put your positive electrode. Then the machine will take the average of the two, the right arm and the left arm. So your negative electrode will be somewhere here. So it will draw an imaginary line connecting the left arm. So it's also splitting this angle into two, 30, 30. So it means if you at lead one, which is straight line here, 0 degrees Celsius, then if you add 30 degrees, you'll be at AVL. So this is the plane for AVL, or the axis for AVL. It's looking at the heart from this angle. So from the left shoulder downwards, this one from the right shoulder downwards, the foot from down upwards. So it's looking at the ventral aspect of the heart. So this is called the cardiac axis. But you appreciate now, since you know the axis for these leads, so you have lead one, then you have lead two, then you have lead three. Lead two, how do you locate lead two? If this is your lead one, which is at 0 degrees Celsius, I mean just 0 degrees, not Celsius, so just 0 degrees. So you can see here, lead two is forming a 60 degrees because I said this is an isosceles triangle. So you have 60 degrees on these corners. So lead two is forming a 60 degrees with lead one. So if this is your lead one, then you add 60 degrees, then you'll be at the axis for lead two. So lead two is at 60 degrees. AVF, I've already told you, it's at 90 degrees. Then the lead three, this one here, you can see it's on the opposite side. So if lead one is 60 degrees here, then the lead two will be 60 degrees from this 180. So if you say 180 minus 60 degrees, it will give you 120. So at 120 degrees, this is where you find your lead three. So you have all the 6 limblings looking at the heart from different angles. So this is called the cardiac axis. So the normal cardiac axis, because those electrical potentials that are being produced by the ventricles, they are moving from the right side of the body towards the left side of the body, and it's moving downwards, that wave of depolarization. So you find that the normal axis of the heart, the acceptable normal axis of the heart, is between -30 degrees all the way to 90 degrees. So this angle here, from -30 degrees all the way to 90 degrees, or from AVL all the way to AVF. This is called normal cardiac axis. So any vector that is found within the normal cardiac axis will give you the normal tracing for the ECG. What do I mean? So you can see here that lead 1 here, if you're looking at this angle, this vector, it's moving more like towards to lead 1. So lead 1 is here. So it's within this sector where you have lead 1, which is positive. So lead 1 is going to produce a positive wave or a positive deflection. When you look at lead 2, this vector is going towards lead 2 and it's positive, going towards positive. You have a positive deflection. So it will give you a positive vector or a positive wave. Same again for AVF. This vector is also more like moving towards AVF. So the AVF will give you a positive deflection. Then when you look at AVR here, the AVR will be negative. Why? It's because this vector is moving away from AVR. And if your positive is here, and this wave of depolarization is moving away from your positive, you get a negative deflection. So it will produce a negative wave. So when you get the 12 lead ECG tracing, you find that the AVR will give you negative waves. So it's normal ECG because of the location of AVR in the cardiac axis. So you need to understand these angles. Okay, so we proceed. So now we're looking at lead 1. So if you draw a circle here, your lead 1 is at 0 degrees. So if your lead 1 is at 0 degrees, any vector in this part of the circle towards lead 1, it means that your lead 1, it will give you a positive deflection. But if the vectors are moving in the opposite direction, so remember, if you split the circle into 2, so you have the semicircle. So this semicircle is towards lead 1. So any vector that is within this semicircle, it will give you a positive deflection. So if it's moving in that direction, that direction, or that direction, it will still give you a positive deflection in lead 1. But if the movement is the other direction, is within the other semicircle, away from lead 1, these waves will give you a negative deflection. So if the heart is producing an electrical activity that is moving away from lead 1, it will give you a negative deflection. Then when you're checking lead 2 is here. So if you draw a semicircle for lead 2, so it means the half the circle, it will be here. This is your diameter, splitting the 2 parts of the circle. So these are semicircles, 2 semicircles. So any vector that is moving towards lead 2, it will give you a positive wave, as shown here. But any vector that is moving away from lead 2, it will give you a negative wave. So anything that is moving the other direction here, it will give you a negative wave in lead 2. So if you get the average of lead 1 and lead 2, what will happen? So if your lead 1 is positive, so you know to say you're looking at this part of the circle, so your lead 1 will be positive. Then if you check your lead 2 is also positive, so you'll be looking at this part of the circle. So let me just use the colors. So for lead 1, you're looking at the yellow color. Then for lead 2, you're looking at the blue color. So the intersection is this dark yellow color or dark blue color. So any vector in this sector whereby lead 1 is positive and also lead 2 is also positive, this is called a normal cardiac axis or the normal axis. So this is a normal cardiac axis. So any vector that is found within this part of the circle where lead 1 is positive and lead 2 is positive, then that is referred to as normal cardiac access. So in simple terms, normal cardiac access is whereby when you're looking at the ECG tracing, your lead 1 is giving you positive wave, then lead 2 is also giving you a positive wave. So once you see that lead 1 is positive, lead 2 is also positive, then you have normal cardiac access. It means that the direction of the heart, the action potentials or the depolarization is within the normal axis. Then so this is normal axis, you can see here. So this angle, like I said, from negative 90 to positive 90, this is regarded as normal cardiac access. So any vector of the heart that is produced in this part of the circle is called normal axis. So in most people, you find that their cardiac vectors is within or is between negative 30 and positive 90. So all that is regarded as a normal cardiac access. So sometimes you can have right deviation or you can have left deviation. So how can you tell that this electrocardiogram recording is showing you a left deviation or a right deviation? So now if you check the ECG and then you find that your lead 1 is positive, shown in yellow here, then your lead 2 is negative. So you can see here, the lead 2 is negative, shown in gray. So it means that your cardiac access, it will be the intersect between lead 1 and lead 2. So if lead 1 is positive, then lead 2 is mainly negative. You can see it's mainly negative here. So it's on the other side. Then your intersection, that's where you're going to have your cardiac access. So you can see that your intersection is between negative 30 and negative 90. So if the cardiac access is between negative 30 and negative 90, this is called the left deviation. So it's called left axis deviation. Left axis deviation. So there are a lot of pathologies that can result into left axis deviation. For instance, when you have left ventricular hypertrophy, left ventricular hypertrophy can result into left axis deviation, meaning that you are going to have a positive wave in lead 1, but you're going to get a negative wave in lead 2. Why? It's because the muscles, they are abnormal in terms of the diameter. They have increased so much that the normal vectors of the heart are changing the direction. So you find that it will deviate into the left axis deviation. So these heart vectors, they'll be between negative 30 and negative 90. So that is called left axis deviation. Then if you check lead 1 is negative, so now if lead 1 is negative, you don't check for lead 2. When lead 1 is negative, you check for AVF. So if lead 1 is negative here, so it means it's this part shown in gray, then you check for AVF. If your AVF is mainly positive, shown in green here, it means that your cardiac access will be the intersect between lead 1 and lead 2. So the intersection between lead 1 and lead 2 here is found between negative 180 or positive 180 and positive 90. So the cardiac access now has deviated to the right. So this is called right axis deviation. Right axis deviation. Then again, if you check your lead 1, it's negative, and your AVF is mainly positive. So you can see here that lead 1 is negative, it's a negative wave. Then AVF is mainly positive. It means that the vectors will be on the other side. So when you want to know now where the cardiac axis will be, it's the intersection between lead 1 and AVF. So you can see the intersection is between 180 and -90. So when the cardiac axis is deviated between 180 and -90, this is called the northwest deviation. Northwest deviation, or sometimes is also referred to as extreme axis deviation. So there are two names: northwest deviation or extreme deviation. So this is very rare. In most cases, you won't find an ECG tracing that will give you northwest deviation. Mostly, you can have left axis deviation that can be due to hypertrophy of the ventricles, the left ventricles. Then you can also have right axis deviation that can also be due to hypertrophy of the right ventricles. So if you have hypertrophy of the right ventricles, most likely you're going to find right axis deviation. So this is how you can use the cardiac axis to help you to come up with certain diagnosis, especially with regard to hypertrophy. It could be right ventricular hypertrophy or left ventricular hypertrophy. And sometimes there are special heart blocks that can also result into deviations that we'll discuss when we start looking at the heart blocks. So these electrodes or these leads that we are discussing here, these are called limb leads. So there are only 6. So remember, we are talking of a 12 lead machine. So now where do the other chest lead come in? So you can see in this diagram that I'm introducing the chest leads. So you still have that normal cardiac axis. You can see you have AVR this side, AVL, lead 1, lead 2, AVF, and lead 3. So we said lead 1 is at 0 degrees Celsius, lead 2 60 degrees Celsius, AVF at 90 degrees Celsius, lead 3 is at 120 degrees, not Celsius, just 120 degrees. Then you have AVR that is found at -150 degrees. Then you have AVL that is at -30 degrees. So we said the normal cardiac axis is between -30 and 90 degrees. This is the normal cardiac axis. So if you're having a deviation, you can have a left deviation, left axis deviation, or you can have a right axis deviation, or you can have extreme deviation, which is also called northwest deviation. Why is it called northwest deviation? It's because when you're looking at this cardiac axis, if this is your north, this will be your south, east, and west. So that deviation is within this segment here. So it will be called northwest deviation. That's why the extreme deviation is also referred to as northwest deviation. Then the chest leads, we said you put them on the fourth intercostal space for V1, V2. So V1 on the right side of the sternum, V2 on the left side of the sternum. Then you go to fifth intercostal space where you put your V3, V4, V5, and V6. So from this diagram, you can appreciate that the chest leads, they are looking at the heart in the horizontal plane. And then the other limb leads, they are looking at the heart in a vertical plane. So you're appreciating this heart from all angles. So you have 12 angles in which you're going to look at the heart. So there are 12 leads. So these 12 leads, they are further divided into leads depending on which aspect of the heart you are looking at. So from this diagram, you'll be able to group these leads depending on which part of the heart are they assessing. Excuse me. So you have lead 2, 3, AVF. So they are here. So from this diagram, you don't need to memorize this table down here. You just need to look at this diagram. You'll be able to group these leads. So you have lead 2, lead 3, and AVF. What are they looking at? They're looking at the inferior aspect of the heart, the bottom of the heart here. This is where they're looking at. So once you have infarction of the apex of the heart or the infarction of the inferior aspect of the heart, the leads that you need to look at on the ECG are lead 3, AVF, and lead 2, because you're looking at the inferior aspect of the heart. So these are grouped as inferior leads. They are inferior leads because you're looking at the inferior aspect of the heart. Then you have lead 1. Then you have AVL, V6, and V5. So you can see these leads, they're looking at the lateral aspect of the heart. So you have this lateral aspect of the heart. So they're looking at the left ventricle of the heart. So the leads that will give you more information about the performance of the left ventricle, you need to look at lead 1, AVL, V6, and V5. So these are looking at the lateral aspect of the heart. And then when you check lead V, V1, and V2 here in the diagram, V1 and V2, they are mainly looking at the anterior aspect of the heart because they are connected on the chest here, just near the sternum. So they are looking direct to the heart. So they're looking at the anterior aspect of the heart or the front part of the heart, in other way. So V1 and V2, they're looking at the anterior aspect of the heart. Then you have V3 and V4. So V3 and V4, they are mainly looking at the septum. So they are called septal leads. So this is how you are going to group the leads depending on which part of the heart they are looking at. So you have the inferior, lead 1, lead 2, lead 3, and AVF. Then you have the lateral, lead 1, AVL, V5, V6. Then you have the anterior, V1, V2. And then you have the septal, this is V3 and V4. So with this information, you'll be able, when you're looking at the ECG machine, you'll be able to tell which part of the heart is affected depending on the information that you are getting on the ECG. So if you have abnormal results on the AVL, lead 1, V6, and V5, then you know to say that the lateral aspect of the heart is not performing well. Then you'll be more concerned with the left ventricle. It could be due to infarction of the left ventricle. You have myocardial infarction of the left ventricle. And if you're looking at maybe lead 2, AVF, and lead 3, then you're looking at the inferior aspect of the heart. So that's how you come up with those diagnoses. So this is just basically the same information. So you can see here that you have these leads, and the 12 leads. So lead 3, AVF, and 2, they're looking at the inferior aspect. Then AVL, 1, V6, V5, the lateral aspect of the heart or the left ventricle. Then you have V1, V2, they are looking at the anterior aspect of the heart or the front part of the heart. Then you have V3, V4 that are looking at the septum of the heart. So this is a tracing for the ECG. So you can see here, you have lead 1, 2, 3. Then you have AVR, AVL, AVF, V1, V2, V3, V4, V5, and V6. So like I said, these leads will give you a picture about a certain portion of the heart. So by looking at this ECG, you'll be able to tell, to say, lead 1, AVL, V5, V6, they're looking at the lateral aspect of the heart. So these will tell you information about the lateral aspect of the heart. Mainly you're talking of the left ventricle. And you know to say that the left ventricle is the most important when you're talking of pumping of blood to the systemic circulation. So any issues with these leads, then you know to say this patient is in trouble. Why? It's because you know to say that these are looking at the lateral aspect of the heart. That's where you have the major function of the heart in terms of pumping. Then you also have the inferior lead. Inferior leads are the ones that are looking at the inferior part of the heart. So you have lead 2, 3, and AVF. These are looking at the inferior portion of the heart. Then you have lead V1 and V2. We said these are looking at the anterior aspect of the heart. Then you have V3 and V4. They are looking at the septum. So sometimes the anterior and the septal leads, they are grouped together, and then they are referred to as anterior septal leads. So these are called anterior septal leads. So the anterior septal lead, you're talking of V1, V2, V3, and V4. Remember, V5 and V6, they are part of lateral leads. So this is how you come up with some diagnosis of heart conditions. So you can see this is just a normal ECG. So from here, you can appreciate that lead 1, you can see the P wave that is followed by the QRIS complex. Then you have the T wave, another P wave, QRIS complex, and a T wave. So from lead 1, lead 2, and V1, this is where you're going to appreciate more of these P waves. So once you know that you have a P wave followed by QRIS complex, P wave followed by QRIS complex, then you know to say that this is normal cardiac rhythm. So this is normal sinus rhythm, if you want a cardiac rhythm. A P wave followed by QRIS complex. But I told you to say AVR, it will give you a negative wave. So you can see here that AVR, it's giving you a negative wave. It doesn't mean that it's abnormal. No, it's because of the cardiac axis. The AVR is on the other side. So the normal cardiac axis is moving towards lead 2 and lead 1. So it's moving away from AVR. So it will give you a negative wave. So you can see you have a bigger S wave in AVR and just a small Q wave and R wave. Sometimes you can't even appreciate that. So this is just a normal ECG. So the second part of this lecture, we'll look at the cardiac arrhythmia. So we'll still have the same ECG tracing, but now with abnormalities. How can you come up with those diagnoses? If you have heart blocks, what would be the behavior of the ECG tracing? If you have cardiac arrhythmias, for instance, if you have more than 2 Ps appearing on the ECG, what does that mean? If you have a missing P wave, what does that mean? If you have excessive contraction in the heart as a result of maybe ectopic sources of action potentials that are stimulating the ventricles that will bring about maybe fibrillation, how does that look on ECG machine? So that's what we'll be discussing in the second part of the lecture. So this is where we're going to end for this lecture. And I've also added a video just to summarize what I was trying to explain. So there is a bit of information. So if you are finding it hard to understand what I was explaining, you can come and watch the video. And next time when we meet during interactive lectures, you can ask those questions and I'll take time to explain for everyone to understand. So this is where we're going to end this class. Next time, we're going to look at the cardiac arrhythmias and heart blocks. So for this part, we are done.